doing Unit 8 review. We're doing it in class, so there's some background noise, but it doesn't really matter. Okay, the sum of the series. First of all, this doesn't say sum of the first 30 terms. It says the sum of the whole series. So we are using our infinite sum formula here, and that formula is a sub 1 over 1 minus r. So, and it just suddenly got much louder in here now that I said I'm going to make a video. So this 5 is my first term over 1 minus r. So you got to go figure out what r is, like what are you multiplying by each time, and what you're multiplying by is a third. If you ever have trouble seeing that, remember that you can take any two successive terms and divide them. So you can do 5/3 divided by 5, right, which would be 5/3 times 1/5, which is 5 over 15, or just cancel those out, so you get 1/3. Okay, and then I'll just go to my calculator, and I'm in math print mode, so I can just put this in, 5 over 1 minus 1/3. Or, you know, you can just put 2/3 as well, please. Okay, oh, what happened? Okay, oh boy, clear. How about, let's try that again. I'll do 2/3. 5 divided by 2/3. Oh goodness. Let's pause this. Okay, I'm going to try one more time here. And then I'm going to do it without the calculator, which would just be easier anyway. Gosh, you know, we're just dividing two fractions. Okay, I'm going to do it. I'm going to worry about the calculator. 5 over 1. If you're dividing two fractions, you keep the first, you change to multiplication. This is 2/3, so when I flip 2/3, it becomes 3/2. So that's 15 over 2. Yay. Okay. We got some clues here. The sixth term of an arithmetic sequence is 8. That's a sub 6. And that'd be a 7th, 8th, 9th, 10th, 11th term is 2. What's the first term? So I need to figure out D in order to do that. So I'm going to think, okay, 1, 2, 3, 4, 5. I got to add D 5 times to 8 to get to that 2. Okay, and now I'll just solve for D. So that's negative 6 over 5. Okay, there's D. Now, you can back it all the way up, sort of manually, to figure out the first term, or you can make yourself a little equation that you can solve. So, using this foundational, it's arithmetic, so n minus 1 times D. Here's what I know. I do know the sixth term, so I can put the 8 here. I don't know the first term. 6 minus 1 times negative 6/5. So 8 equals a sub 1 plus, so this is 5 times negative 6/5. Those will cancel, and it becomes negative 6. Okay, so then I'll just add 6 to both sides, and I'll find that a sub 1 is 14. Okay, next up, here's a nice sequence. Find a sub 30. So the first thing to decide is, hey, what kind of sequence do I have here? Because it doesn't say. It looks to me like I'm adding the same number each time. So D is 3. This is an arithmetic sequence. I'll need my formula. I'm seeing a lot of folks not putting this plus sign in here, and that's just really messing it up. If you want to find the 30th term, you put the first term here. This will become 30 minus 1, 29 times 3. So I'll just go to my calculator, except apparently my calculator doesn't work. So maybe I should get a new one. Yeah. Let me get my calculator out. I don't know what's wrong with that. I don't know how to reset it either, so that's for another day. Okay. 1 plus 29 times 3 probably has something to do with my freshman class. Just, yeah, that's hilarious, you know, that you fixed it. Okay, so the 30th term would be 88. Okay, here's a sequence. First, again, we have to decide, are we adding here or are we multiplying? I've got a hunch that we are multiplying. So I'm going to make sure I'm going to do the second term divided by the first term, right? That's how you can find R. So that's negative 8/3 divided by 4/1 means times 4/1. Sorry, 1/4. Keep, change, and flip. Okay. So we can cancel this and make this a -2. Negative 2/3. That's what I think R is. Now, we can check that. Okay, is negative 8/3 times negative 2/3 16/9? Yes, it is. So that is the value of R. All right. So now I can write an explicit rule and a recursive rule to write. This is geometric, so I'm working off of this. A sub n, first term goes here, R goes here, to the n minus 1 power. That's explicit. For recursive, I have to state what the first term is, and then say, okay, to find the nth term, take the previous term and multiply it by negative 2/3. All right. Find the 4 geometric means between 160 and 5. So 160, 1, 2, 3, 4, 5. And I'm a visual person, so I got to write all this out. Okay. Each time we're multiplying by R here. So every step is a multiplication because it tells me it's geometric. Geometric means. So my equation would be 160 R to the 5th equals 5. Divide by 160, and we'll simplify this fraction. It becomes 1/32. Okay, I'll take the 5th root of both sides. And the 5th root of 1 is 1. 5th root of 32 is 2. So R is 1/2. So if I'm going to find the geometric means, I'm just going to multiply by 1/2 each time. So times 1/2, we get 80. Times 1/2, you get 40. Times 1/2, 20. Times 1/2, 10. Times 1/2, 5. So it kind of checks out. I get reassurance that I did it correctly because 10 times 1/2 is 5. Okay, geometric sequence, find the 7th term. So again, I'm grabbing this formula. This is the formula for the 7th, for any term. Put the first term there. We got to go figure out what R is again. So again, if it's not obvious to you what R is, because I'm not sure this one's super obvious, don't forget that you can do, and I know it's geometric because it says it is. You can do the second term divided by the first term. So that's -3/2 times 1/2, right? Because keep, change to multiplication, flip over. -3/4, that's R. -3/4. Yeah, that checks out. -3/2 times -3/4 is 9/8, so that's good. To the n minus 1 power. Okay, so if I want to find the 7th term, it's a sub 7, -3/4 to the 6th power. And because I don't actually, I could probably do that in my head, but do I really want to? Not really. So I'm going to go ahead and put that in the calculator here. So 2, and then I have -3 divided by 4. Close the parentheses to the 6th power. I don't like that though, do I? No, I do not. I want that as a fraction. I think I'll do it as a fraction. So let's see, -3 to the 6th power, right? This is 2/1. -3 to the 6th power is the same thing as 3 to the 6th power because I know it's an even power. So you can either do that or you could do -3 to the 6th power. It's going to be the same thing because that's an even power, right? So that's 2/1 times 729 over, and now I'll do 4 to the 6th power. 4,096. Okay. Now I can simplify this right now without, you know, too much hassle by crossing out a 2 here and then dividing this by 2. So I'll get 729 over 2,048. I like that answer better than that decimal. Yeah. Okay. Person has 2 parents, 4 grandparents, 8 great-grandparents, and so on. Determine the number of ancestors in the 8 generations preceding his or her own generation. So here's our sequence. And on and on and on. If you want the number of ancestors, it's a total number of ancestors in the previous generations. So that's your sum formula. This is a geometric sequence with r equals 2. So you need that sum formula, which of course I have to probably go look at. 1 minus r to the n over 1 minus r. And I'll pop in the pieces that I know. First term 2, 1 minus 2 to the 8 generations, so 8 is n, over 1 minus 2. Okay, and I'll go to my calculator here. And again, I like to be in the math print mode, so I can use that button. 1 minus 2 to the 8th power. Close the parentheses, all over 1 minus 2, which is just negative 1. 510 ancestors in the previous generations. The sum, right? That's all generations. That's a lot. Okay, determine the sum of the first 25 positive even integers. So here's my sequence.
I don't do that.
And let's see, 2, 4, 6, 8, 10. So this is a arithmetic sequence, and D is 2 because you're adding 2 each time. You want sum, so go grab your sum formula. This is arithmetic, so you're going to grab this formula. And then I'm going to pop in the pieces that I know. 25, sum of the first 25, so 25 over 2, 2 times 2, plus 25 minus 1 times 2. Okay, so this is 12.5, 4, plus 24 times 2, 48. So 12.5 times 52, 650. Okay. I'm going to pause. Okay, let's do a couple more and then I'm going to make another video for the back. Geometric sequence. A sub 1 is r, is 2, r is 3. If the sum of the first n terms is, that number, find n. Okay, so I need my sum formula for geometric. So I'm just going to start by writing that down. What is it again? A sub 1, 1 minus r to the n over 1 minus r. Okay, I know my sum. 531,440. I know a sub 1, so I'll put that there. I know r. I don't know n, so I have to put an n there. Oh, I do know r. It's 3. So let's put a 3 there. All over 1 minus 3. I hope it's okay. I'm just going to put negative 2 right now.
Wait, is our class going to be based
on I don't know. I'm making a video real quick, so hold on. Okay, so next I'm going to have to solve for n. So I'm dividing 2 over negative 2, so that becomes negative 1. These will kind of cancel and simplify. Negative 1, 1 minus 3 to the n equals this number. I'm limited on space here. Distribute. We're just trying to get n. Negative 1 plus 3 to the n. Trying to get n by itself. So I'm going to add 1 to both sides. 441 equals 3 to the n power. Okay. Now, this is an exponential function. So to solve an exponential, right, 3 to the n power equals this number, I have to do the switcheroo. So that's log base 3 531, 441. I should have gotten more excited about that. I got to do the switcheroo equals n. Okay, now I can go to my calculator. Got to use that change of base rule. So I can do natural log of 531, 441, and divide that by the natural log of 3, and I get 12. Okay, last one, and then I'm going to take a little break. Determine the 4 arithmetic means between 1 and 36. 1, 2, 3, 4, 36. How many times do you have to add d? 5 times. 1 plus 5d equals 36. Subtract 1 from both sides, and you get 35. D is 7. So I'm going to add that each time. 8, 15, 22, 20. It's your birthday! Hey, happy birthday! When is it? Today. Oh my goodness, happy birthday. That's fantastic. Bye. Yeah, there they are. Done.